In this section, we will focus on threat modeling activities as part of the broader topic of governance, risk, and compliance. Understanding how to perform threat modeling is crucial for identifying potential threats and mitigating risks to protect systems and data effectively. This skill is not just a key component of the SecurityX certification, but also an essential practice in any robust security strategy. We'll explore various scenarios to help you develop the expertise needed to analyze and address threats competently. In this section, we'll delve into the crucial concept of threat modeling. Threat modeling is a proactive process in cybersecurity. It begins with identifying potential threats that could impact your system or data. Once potential threats are identified, the next step is to evaluate the risks associated with these threats, understanding their potential impact and likelihood. After assessing these risks, the final step is to define and implement measures to mitigate them. Threat modeling is essential because it helps in securing systems and data from potential threats before they can be exploited. It's not only a critical practice for maintaining security, but also an integral part of the SecurityX certification. By mastering threat modeling, you're equipping yourself with the skills necessary to preemptively address security vulnerabilities, which is a vital asset in any cybersecurity strategy. Now let's dive into the methods of threat modeling, which will help us identify and address potential security issues more effectively. First, we have abuse cases. These are scenarios that focus on how the system might be misused. A common example would be insider threats, where individuals within the organization may exploit their access privileges to compromise the system. Next, we have anti-patterns. These help us identify common faulty practices that can lead to vulnerabilities. An example here would be reusing passwords across multiple systems, a practice that can severely undermine security. Finally, we have attack trees graphs, which provide a visual representation of potential attacks. For instance, you might map out the steps an attacker could take to compromise a server. This method helps in visualizing the attack vectors and developing strategies to counter them. These methods are crucial in understanding and mitigating threats, ensuring a robust security posture for our systems. In this slide, we're focusing on abuse cases in the context of threat modeling. Abuse cases are scenarios that describe how a system can be misused, detailing the potential threats that could arise from such misuse. For example, consider a legitimate user who gains access to unauthorized data. To mitigate such risks, implementing the principle of least privilege is crucial. This means users should only have the minimum level of access necessary to perform their tasks, reducing the chance of misuse. To aid in generating and analyzing abuse cases, you can utilize tools such as AbuseCaseTool. An example command to generate an abuse case for unauthorized access would be AbuseTool generate-case unauthorized access. This command helps automate the creation of abuse scenarios, making it easier to identify and mitigate potential threats. Now we'll discuss antipatterns in threat modeling. Definition: antipatterns refer to commonly identified poor practices in threat modeling that can lead to vulnerabilities. These are the actions or choices that, although they might seem suitable or effective, actually open up the system to potential abuse or threats. Practical example: a typical antipattern is hard-coding sensitive information such as passwords or API keys directly into the source code. This practice can lead to significant security risks, such as easy exfiltration of data by attackers who gain access to the codebase. Mitigation: to avoid such antipatterns, use configuration management tools to securely manage sensitive information. These tools help in separating configuration data from the code, allowing for better security and easier management. Tool: the AntiPatternAnalyzer can be utilized to identify and eliminate these poor practices. Command example: to scan your project directory for potential antipatterns, you can use the following command: shell AntiPatternAnalyzer scan/project/path. By recognizing and addressing these antipatterns, we can strengthen our threat modeling processes and enhance the security posture of our systems. Attack trees or attack graphs are powerful tools in threat modeling. They provide a hierarchical model that outlines potential attack paths, helping security teams to visualize and understand how an attacker might achieve their goals. To build an attack tree, start by identifying the primary objective or goal, such as data exfiltration or access to sensitive data. This will form the root node of your tree. From there, break down the necessary steps an attacker must take to reach that goal into child nodes. For example, if your root node is access sensitive data, potential child nodes could include credential theft and network sniffing. This method not only helps in outlining potential threats, but also assists in identifying where security measures can be effectively implemented to thwart such attacks. Now, let's dive into creating attack trees. For this, we can utilize a tool called AttackTreeBuilder. This tool allows us to visually create and analyze attack trees, simplifying the process of mapping out potential attack paths. To generate an attack tree for a specific type of attack, such as phishing, you can use the following command: AttackTreeBuilder generate type phishing. This command helps create a tree that outlines all the steps and elements involved in executing a phishing attack. Once you have an attack tree, you can analyze it for vulnerabilities using a similar command. For example, AttackTreeBuilder analyze/path-to-tree. This will provide insights into vulnerabilities and weak points within the attack tree structure, enabling you to implement better security controls. Now let's discuss the modeling applicability of threats. When it comes to existing systems, it is crucial to evaluate the current control measures. By doing so, you can identify gaps in the existing security and select appropriate controls to fill these gaps. On the other hand, if you're dealing with a scenario where no current systems are in place, you need to implement new security frameworks. This proactive approach to threat modeling will help guide your design decisions, ensuring the system is secure from the ground up. This dual approach helps in both enhancing the security of existing systems and in building robust new systems that are prepared for potential threats. In this slide, we will focus on threat modeling with existing systems, specifically using the example of a web application. First, we need to evaluate the current control measures in place, such as the firewall and web application firewall (AF) controls. By assessing these existing security measures, we can identify potential points of exploitation that malicious actors might target. Subsequently, it becomes crucial to select and implement additional controls to bolster the application's defenses. For instance, adding DDoS protection can further mitigate risks. To facilitate this process, the tool Control Evaluator is recommended. You can use this tool to scan your existing system and evaluate its security controls. For a practical example, you'd run the command Control Evaluator scan existing/system. This command helps you comprehensively analyze the current setup and pinpoint areas requiring enhancements. In this slide, we're shifting our focus to threat modeling from scratch, specifically for a new IoT device scenario. First, we need to identify potential attack vectors, which include both physical and network vulnerabilities. Given the nature of IoT devices, it's crucial to consider how someone could physically tamper with the devices, as well as how they might exploit network communications. Next, it's important to implement initial security controls. This could involve encrypting data to protect it during transmission and setting up a regular schedule for firmware updates to ensure any vulnerabilities are patched promptly. As threats evolve, you should regularly update your threat model. This continuous attention helps in staying ahead of potential attacks and reinforces the security posture of your IoT device. For this process, we use the tool Threat Modeler. You can initialize your modeling with a command like sh-threat-modeler init device IoT sensor. This command sets up the initial parameters for the IoT device, aiding in the detailed modeling of threats and planning of defenses. Understanding and applying these foundational steps is key in securing new IoT devices from the start, thus ensuring they remain secure throughout their lifecycle. In conclusion, we've covered the essential aspects of threat modeling to protect your assets effectively. The importance of threat modeling can't be overstated. It provides a structured approach to identifying and mitigating potential security threats. The techniques we explored, including abuse cases, anti-patterns, and attack trees, offer diverse methodologies to uncover and address vulnerabilities. We also discussed tools such as AbuseCaseTool, AntiPatternAnalyzer, and AttackTreeBuilder, which can facilitate the implementation of these techniques. Remember, incorporating threat modeling early in the development lifecycle is crucial, and it's equally important to update your models regularly as systems and threats evolve. By doing this, you ensure a more robust security posture for your projects. On this slide, we have a list of references that will further aid your understanding and implementation of threat modeling within your security practices. For reading materials, I highly recommend Threat Modeling: Designing for Security by Adam Shostack. This book offers deep insights and practical advice on designing secure systems. Additionally, the OWASP Threat Modeling Cheat Sheet can serve as an excellent quick reference guide for key concepts and strategies. We also provide documentation and resources for the tools discussed earlier. The AbuseCaseTool Documentation, available on its official site, offers detailed guidance on how to create and manage abuse cases effectively. The AntiPatternAnalyzer GitHub repository contains the codebase and contribution guidelines for you to explore and perhaps even enhance its capabilities. Lastly, the AttackTreeBuilder user guide will walk you through the steps to build and analyze attack trees, providing a robust framework to anticipate and mitigate potential threats. Thank you for your time and attention throughout this course. We hope you found the content useful and engaging. If you did enjoy the material presented, please give us a like. Your comments are invaluable to us, so feel free to leave any thoughts or feedback below. Don't forget to subscribe to the channel for more learning opportunities. Lastly, if you think others could benefit from this course, share it with your friends and colleagues. Thank you again for your participation. Thank you for following along with the course. If you enjoyed the content, please leave a like and consider commenting below with your thoughts and feedback. Don't forget to subscribe to the channel to stay updated with future courses and content. Also, feel free to share this course with your friends and colleagues who might find it beneficial. Your support is greatly appreciated.